Hello, everyone. I'm David. I think it's my third time potentially introducing myself. I am the product lead for two products that Protocol Labs develops to make things easier to use IPFS and Filecoin in your applications. So I'm here to tell you about them today. And for all y'all who are hacking out there and are interested in using very simple to use services to actually have your the data you're storing out on the web be decentralized, then please do check us out. So what are NFT.storage and Web3.storage? At a high level, they are sister storage products and services. On one hand, that provide the ease of use and performance that we're all kind of used to these days with traditional cloud storage. The whole 2 lines of code, high performance, high availability, that sort of thing. Alongside being able to use as your primitives and how you address data, IPFS CIDs, as well as decentralized storage on the Filecoin network, where you don't actually have to trust us that we're storing your data for the promised amount of time. You can always just check the proofs out on the Filecoin blockchain. And actually, last time I gave this talk, there was an entire 50-minute session before explaining what IPFS and Filecoin do at the core. So it's a little bit light on the details here on that, so I'll try to inject some of that in. But if you ever want to learn more about what IPFS and Filecoin are, they have great docs websites that can give you kind of an overview of what the technologies are at the core and why they're really important. So framed a little bit differently, maybe from the user's point of view, NFT.storage and Web3.storage on the surface give you simple, familiar, and performant interfaces. So on the storage side, you install your client library. You can store things real quick. Things get uploaded to Cloudflare Edge workers, so it's highly available, fast. On the retrieval side, you can use HTTP URLs to retrieve your data, even though they're on the IPFS network, because as part of that HTTP URL, you include the IPFS CID there. But underneath the surface, there's all sorts of complexity. And I think for the longest time with users of IPFS and Filecoin, because folks are trying to build services on top of them, what ends up happening is that folks who are just at a hackathon and interested in using IPFS, they end up having to get really, really in the weeds on stuff. They have to, and peer-to-peer things don't always go right. You can have a firewall, and then more generally, a lot of the technology is in motion. For your specific use case, you have to get really deep into the data structures of things. On the Filecoin side, you have to run a node and sync that entire chain and all that. And it can be really intimidating for a large tranche of users, and even those who have the motivation to get underneath the hood a little bit more can be difficult to understand. So we try to save users from all that, and the interface in between the ease of use and what's going on underneath the hood are CIDs. CIDs are content IDs. They're the primitive that IPFS uses to reference data. They're a hash of the data itself. So the coolest thing about CIDs, one of many cool things about CIDs is that you actually don't have to trust anyone when you're storing and retrieving data using CIDs, as long as you're computing that CID on the client side when you're storing it, and then when you're retrieving it, you can always validate that the data you're getting back matches up with that CID just by hashing it. So I'll talk a little bit more about this in a second, but that's really what differentiates NFT.storage and Web3.storage as products versus more traditional cloud storage providers. And then once you're kind of on the services today, they are very simple and get your data on there, and you can build a lot already on top of that. But there's all sorts of Web3 innovations that are coming along, both from the IPFS and Filecoin communities. So if you look at the bottom here, there's all sorts of exciting stuff coming from Filecoin that will increasingly decentralize services like ourselves even out of the picture, where you can interact more directly with decentralized storage networks, as well as secret sauce that we're including in our services to make it so that you can pretty much build anything that you can today, but using trustless Web3 technologies. I've kind of glossed over this thus far, but NFT.storage and Web3.storage are two different products. And they share similarities at the service and infrastructure layer, but they're really two different products with two different goals and I'll double click into that a little bit more. And yeah, you can maybe read through the bullets here, but I'm going to voice it all over in the following slides. So I'll start with what they do share. So with that intersection of the Venn diagram, the goal for both these products is to provide production-ready decentralized storage. So Web3 is really in the public eye today. Applications have real users. These applications sometimes have tens and hundreds of billions of dollars invested in them or valued in them. And you can still go to a top NFT marketplace and wait 5 minutes for all the images to load on there. We're in a trial period, and there is more and more attention, and there's a lot of really passionate community members who are willing to be patient. But the faster we can get to where we are today with the web more generally, the faster that others will be able to take advantage of what Web3 is building. And that in the end, the vast majority of folks aren't making decisions on how decentralized something is or is not. They just want things to work. So end users and developers both demand from their storage solutions specifically fast and reliable storage, CDN speed retrieval, infrastructure that can scale to whatever they need, and just simply the ability to store any sort of data. And it could be data size or file types or like video and have it formatted in a way where you can stream it and all that stuff. And it just got to work in the end. So what we do is structure our infrastructure to lean into a lot of existing cloud infrastructure done in a way where we're not locked into them and we don't have to trust them, but taking advantage of the fact that, hey, a lot of cool technologies have been built to be able to solve a lot of the problems of performance and reliability and that sort of thing. I still think it's really cool that you can snap your fingers and the amount of storage that you're paying someone for can elastically 10x, right? Like, gone are the days of a restaurant having to run their website in the server in the back room, and they get like half an hour of some developers' time a week to like debug any issues, and they can be down for multiple weeks as a result and things like that. So we want to lean into the innovations that exist to provide that sort of service level to our users. At the same time, we can't just recreate AWS or whatever. We need to maintain trustlessness in the system. So gave a quick overview of IPFS CIDs before, and I would encourage you to read more in depth about it. But what it comes down to is as long as you can trust the cryptography, you don't have to trust the services you're using. So with Web3.storage and NFT.storage, content addressing and Filecoin proofs are the star. So the first two kind of sub-bullets in the second bullet up here, they reference what content addressing does for you. So before uploading any data to NFT.storage and Web3.storage, you compute the CID of that data locally. So you take the content, you compute its hash, and you know that's the hash of the data. That is a property of the data itself. No matter who gives that data to you in the future or whatever, you can always verify that. And that's what you're going to end up referencing the data with when you pull it down from IPFS. And then I guess that is the trustlessness created from like that data layer of using our services. There's still the infrastructure layer where maybe you don't have to rely on us or be locked into us to be able to reference your data in a universal way, but you're still relying on us to be up. And how do you know that your data is safe? Well, if we go down, we do store all the data in Filecoin deals on the Filecoin network, 6+ replicas across independent storage providers. And you can always, at any time, check the Filecoin blockchain to verify that this data is safe. So really quickly, Filecoin is a type of IPFS, but it comes with some extra secret sauce where Filecoin storage providers who say they're storing your data have to periodically submit cryptographic proofs validated by the network and end up on the blockchain that your data is being stored for a specific duration of time, the exact data with that exact storage provider. So don't have to trust us. Check the Filecoin blockchain. It's all in the cryptography that your data is safe. And then, yeah, once the data is on the network, you can pull it down in a multitude of ways. You just locally can verify it's correct if you need to make things fully trustless. And one cool thing about IPFS, another cool thing about IPFS, is that you can store more copies of the data wherever you like. You're not locked into us in any way. Store the data in as many places as you need to feel comfortable. We're just able to provide a simple on-ramp for you to get the data onto the network in the first place. Zooming in a little bit more on NFT.storage and how it differs from Web3.storage. So we talked more about the similarities so far. NFT.storage, the mission initially was to really drive home IPFS CIDs as the standard in NFTs. And the way we sought to do this is kind of like two-pronged. So first, making it super easy and simple to be able to generate IPFS CIDs for your data. So as a reminder, NFTs don't store all their data on-chain in the NFT itself. They make references to off-chain data. And it's really important for that off-chain reference to be a unique property of the data itself. So no one can ever argue with you that that data is actually the data that your NFT is referring to. So making this as easy as possible will help make IPFS CIDs kind of the primitive here. And at the same time, the other side of the problem with NFTs and the off-chain data side is that the data actually has to be available. So if you ask the IPFS network, hey, here's my CID, give it back to me, you should be able to get it back. And we want to be one of the folks who are able to provide a trustless, decentralized, multi-generational, decentralized storage option for NFTs. So by storing it into Filecoin. And Filecoin deals are finite. So today we're renewing those deals manually, and we monitor the Filecoin chain to kind of make sure that at least X number of copies are on the data at any point. But the plan in the future is to increasingly decentralize ourselves, instrument things like smart contracts. We'll do this listening for you, always spin up new Filecoin storage deals to keep the number of copies and the redundancy up to a certain point, even as deals expire or go offline, and fund this all through an endowment in a DAO. So that's kind of like the high-level vision of NFT.storage, and it's really transformed things into the mission being enabling NFT persistence as a public good. And really, the potential of NFTs is to be an immutable data graph of the web. When you think about what the internet initially was vision-wise, it was trying to create a graph of data out there that was publicly accessible. And there's institutions like the Internet Archive and others looking to preserve that sort of thing. We think NFTs are going to be a big part of the story moving forward. So with NFTs, all the parts that are on-chain are obviously immutable. We just want to make sure that that off-chain component can still maintain that data graph, because the NFTs without that off-chain component really lose a lot of their value. Talked a little bit about the decentralization mechanisms that we're hoping to use. One other thing I'll call out, or two other things I'll call out. It's free to store data on NFT.storage, and it will be persisted for free. We are able to do that today because Filecoin storage is extremely cheap today. It's, I think, something like 1,000? Some number of zeros in scientific notation, I don't know, but cheaper than S3 storage per unit of data stored. And the other thing I wanted to mention was we are in the background doing something called Nifty Save, where we're scraping the chains out there that contain NFTs and persisting that off-chain data for folks. And if you are already using IPFS, you immediately get another copy of that data that is just helpful for your redundancy, makes it more likely that that data can be retrieved more quickly. A lot of NFTs were minted via things like HTTP URLs. So now you have a minting transaction for an NFT that is referencing an HTTP URL, and we have separately stored a copy that is content addressed. The plan is to publish a data structure mapping all NFTs to the CIDs of them. So now folks who use an HTTP URL originally, but now that server has disappeared or someone forgot to pay their storage bill or whatever, they can reference this data structure to get back their NFT data. That's kind of the end-to-end mission here. We're iterating more over time to kind of fulfill this vision. But if you are storing any NFT data out there and you just want an easy-to-use experience that maybe you're excited about our mission, maybe you're a little skeptical, whatever, no cost to try it out and store your data everywhere else that you need to make yourself feel comfortable. And moving on to the Web3.storage side, it's, again, very similar product, but the difference here is it's much more generalized. It's really there for any storage use case out there. So it's no longer trying to store data as a public good, but any other storage use case out there, check out Web3.storage, and you can really build whatever on top of us. It can be an end-user facing application. You can build developer tooling or even instrument another storage service on top of us and use us as that dumb storage layer. We're looking to unlock the potential of Web3 and IPFS CIDs, bringing Web3 more to the web, and want to enable all the creativity out there. 1 terabyte is always free for new users. Today, it's also free. Beyond that, there's some weird thing where you request more storage from us, and we check out that you have a real project. And again, Filecoin is cheap. Filecoin storage is cheap today, so we can do this. But we're moving to a more transparent model in the future, likely where users stake Filecoin to unlock more storage. So in case that's a little bit confusing to you as you check us out, do keep that in mind. And really, the roadmap for Web3.storage is to unleash the potential of Web3 by bringing in new features that embrace the fact that every entity in the network has their own decentralized identity, and you can use cryptography to securely, make sure that so-and-so has permissions to do what, or granting permissions. We just launched UCAN authorization in NFT.storage. We'll bring that over to Web3.storage soon. And then you can see new data access patterns potentially where individual end users all have Web3.storage accounts, and now they're using UCANs to authorize applications to use that storage on their behalf. And now that model of data ownership for end users is kind of unlocked versus you trusting that this application is going to do all the storage for you. I won't go too deep into the other stuff, but a lot on the horizon to be really excited about here. And I'll close on a quick teaser for those who are looking to do some hacking this week on how to use us today. Go visit the website of the product that feels like it fits your use case, create an account, and make a key, install the client library. You get a CID by one line of code, and you store it with another line of code, and then you retrieve that data at any point using that CID. Easiest thing to do would be to use an HTTP gateway, but depending on your application, you might want to spin up your own IPFS node to do that, or use other retrieval methods. Yeah, check us out. We got websites, we got docs, we got Discords. Follow at NFT_storage on Twitter. I run the account, so it'll be fun. And I think that's all I had. If folks in the audience had any questions, happy to answer them. Otherwise, or I don't know if we have a chat for people streaming, if there's a chat for questions, but otherwise, can move on to the next stuff. Does she need a microphone? Yeah.
If the content is hashed locally and validated locally, then how are third-party applications getting access to that data?
Do you mind defining what you mean by invalidated?
Oh, validated.
Oh, validated locally. How are third-party applications going to use it?
Yeah.
So that would just happen at the application layer. So depending on your structure. One simple example of folks using NFT.storage is OpenSea uses NFT.storage when you use their freeze metadata feature when minting an NFT. You click on that. OpenSea has you compute that CID locally, but then OpenSea will keep a copy of what that CID is in their databases and stuff like that. That CID also ends up in the minting transaction for the NFT. So now it's open and anyone can see what the CID is associated with your given NFT. So now everyone kind of knows what that is. And it becomes public at that point. So anyone can pull down that data with that CID. And if they want to validate that that data is proper, then they can always run the hash themselves. But one kind of crazy thought exercise is thinking about all the weird data access patterns that you can enable using CIDs at the core. So this is something that looks very traditional with the additional component of trustlessness of the transactions on the blockchain telling you what this NFT was associated with the CID, authorized by so-and-so, like public key or whatever. But yeah, I mean, you can get kind of crazy with all the things that you can unlock.
Just to follow up, is there anything keeping track of the various, I guess, nodes? I'm not really sure how IPFS is structured. The various nodes that have validated this CID, or like basically anyone who's used it at some point?
So not really. I mean, you can look in the IPFS network. Like IPFS has a few different ways to provide content to each other. So that's all public. You can see what nodes are broadcasting what content. I guess I'm not a deep expert on this, but I guess like a node could lie about what content they have and then try to maliciously send you the wrong content. But again, that's kind of the point of being able to verify things locally.
Got it. Thank you.
Yeah.
Hi, I was just wondering if IPFS is working on anything for decentralized structured data, like databases?
Yeah, so I guess in terms of what IPFS quote unquote is working on, like it's a big open source community with a lot of folks building on it, and there are definitely people who are trying to build this use case. I can talk a little bit about what our team at NFT.storage and Web3.storage are doing, where yeah, we're totally looking to enable databases to be built on top of us. So one kind of tangible thing we're doing right now, most IPFS infrastructure speaks in ways of like pins in IPFS, and a pin needs to be a complete graph of data. But we're moving to infrastructure where you can actually have like incomplete graphs of data and be able to serve up that data. So you can start unlocking database use cases on top of us by like focusing on like the diffs and that sort of thing. So yeah, IPFS is super broad. All it means is I can access data, I can reference data using this like CID, this hash of the data. What you build underneath the surface is like more to do with the implementation of it.
There's a couple other teams working on IPFS-based database projects. So Orbit DB is one. Tableland is doing something.
Oh yeah, check out Tableland. They're cool.
Yeah, it's really cool. So it's definitely kind of the frontiers of IPFS development, but there's some cool stuff coming.
Thank you.
All right, I think that might be it. Thanks for your time, everyone.